Right. Last session we have finished about what? Switching STP and the port fast, and have given some tasks, right? Like the switch router connected to different VLANs communication by connecting to different links, and one switch, one router by creating sub interfaces. Without router, layer 3 switch, different VLAN communication. The task. And two different switches with one router, different VLANs communication. So today, let me continue with one more scenario here. See, the network topology is the first one is your branch one router. The middle one is a head office, and last one is branch office 2. What type of topology is this? Branch 1 is connected to head office, branch 2 is connected to head office. What type of topology is this? The full mesh topology or partial mesh topology or hub and spoke topology, or we can call it a star topology. Like which topology is this? Yes, Shiva. See, branch 1 is connected to head office and branch 2 is connected to head office, right? Like multiple branches connected to head office means is a perfect, is a star topology. So star topology, or we can call it is what? Hub and spoke topology, right? Okay. Now IP conditions between this diagram. Condition number 1, branch office LAN interface, fast Ethernet interface. IP address, classic example 2.1 2.1 /24. For head office LAN, I'm making this here 10.0.0.1/8. For branch 2, 192.168 3.1/24. Now, based on this condition, your LAN interfaces and your end user's IP address should be in what? Same network, right? Okay, let me assign our end user IP addresses also. For first end user, let me configure with 2.10 and second device 2.20, 2.30. Head office router 10.1, the end user devices 10.10, 10.20, and let's consider this is my organization server. So this server means you can use any example. My example is it is a FTP server or can be a mail server. The server IP address is 10.0.0.100 have assigned static IP. For branch 2 IP is what? 3.1. End user IP should be in same network. 3.10, 3.20, 3.30. This is IP condition, right? Even the next condition is CL interface IP between head office and branch office should be in same network. Same condition we have used. Okay. Okay, now my simple question is like how to enable communication from branch office 1 LAN users to head office LAN users, head office LAN users to branch office over to LAN users. Like how to enable communication for LAN to LAN. It's very good. Like by enabling what? Routing. It can be static routing or it can be dynamic routing also. So based upon your requirement and based upon your network design, we need to enable what? Routing. So in my example, I have configured RIP in branch 1, RIP in head office, RIP in branch 2. I have configured RIP in all 3 branches. Now you tell me guys, like all branches can communicate? Yes or no? Yes, they can communicate, right? Okay. So let's consider in branch 1, LAN users are 100 users. In head office router have a 200 users. In branch 2 have a 150 users. Anyhow, in the real time, if you go for, we can get more than this number also. Just for example, to understand, I'm telling is small numbers, 100 users, 200 users, and 150 users. So now you tell me people like all users, like how many users can access now your server? It can be FTP server or mail server. How many users can access the server? 450 users, right? Like from 100 from branch 1, 200 from head office, and 150 from branch 2. Like all 450 users traffic is coming to one server. Now, how about server performance? Getting slow, right? Basically, server performance got slow. So 450 is only my small example. Like in real time, we can get what? More than very large number, right? So number of users traffic is coming to one server, server performance is down, then or slow. Like how we can improve our network performance is our main question here. How? So how we can improve our main our server network access, network performance. VLANs. See, VLANs means what? VLANs is a virtual LAN. It's a local network only. So VLANs can be managed only local network, but not traffic is coming from outside, right? And how you can manage it? So VLAN concept is we already discussed clearly. VLAN can provide only layer 2 security, the local only, right? But now traffic is coming from branch 1 and branch 2. How can control it? Like how we can improve the network performance? Right, all right. I have a small question here. Let me ask my small question. At present, you are using internet, right? At your homes or anywhere. You have internet access from home. Do you share your passport to others? Generally, do you share your passport to others? No. Why? What happen if you share your internet password to others? So if you share your password to others, like others can access your data, then your network is what? Slow. Right? So not only you, like if you share your password to others, like what others can do? So daily they can access there, maybe they can download the movies and your performance, your bandwidth is being wasted, completely finished, and your network will become what? Slow. This is one reason, one of the reason. What is the main reason why we are not sharing for password to others? Means if you share password to others, like others can enter into your network and they can do something. So then your network is not secure. Right? Then how we are securing our network? Basically, we have one little bit idea, right? That is what we are setting a password to your Wi-Fi. It's a basic security, very basic. So if you don't have any password to your Wi-Fi, like your internet, now others can access easily. Just directly can see the name and you can enter and you can access. So generally, without any knowledge, everyone can provide the security also for your Wi-Fi. How? They're setting some small password. Right? So means what exactly here means we are restricting others, we are controlling others. Anyway, the main reason security is only one point in network security, which is controlling users traffic. In generally, if you see any organization, any companies, very big companies or small companies, in front of the company we have a security guard. 3 members or 4 members or 5 members, it depends upon the organization sizes or whatever, right? So what exactly they will do job? When outside traffic is coming, they'll stop them, right? They'll stop and will check the examine. So you're from where you are coming, you have a permission, you have ID cards, everything will check it. So if you have a proper permission, then only the person is going to allow, right? If you don't have a proper permission, what the person will do? Will block you, right? Will deny you. Why? So why? Because security reasons, they're controlling the user's traffic, right? Same thing here also, network traffic. When branch office 100 users is trying to access my server, like I don't want to allow all 100 users, I want to control some users here. Like out of 100 users, I want to permit only limited users. Let me take one small example here. Instead of 100 users, as per our diagram, network diagram, like 2.1, 2.10, 2.20, 2.30, three computers. Like out of three users, like 2.10, first user should not communicate my network, should not access my LAN or head office LAN or head office resources, should not communicate. Similarly, 2.20 users also 2.20 user also should not access my LAN. This is my rules, these are my policies. Now what I'm doing is 2.30 user, yeah, we can allow. So I am permitting 2.30, but not full permissions. For the permission, he can permit only for what? FTP, but no other service. Or maybe 2.30, I can permit only for mail service, no remaining other. So these are all the rules, these are all the policies I'm going to write. The same thing in branch office too. In branch office too, out of 150 users, let me take one example here. 3.10 user should not access my network. But 3.30 also should not access my network. 3.20 user, I'm going to allow him 3.20. So 3.20 should allow only for FTP service. I'm permitting, but which service I'm permitted? Only FTP, no other service. Like I have defined the rules. Now, when traffic is coming from outside, we required one security guard. We examine which traffic has to permit, which traffic has to deny, right? We required one dedicated security guard. So that dedicated security guard device is called firewall. Let me open the browser and let me check what type of firewalls the market is present. Have so many firewalls is it? Let's see firewall vendors. You see in the list here, have a very big list here, like Fortinet, FortiGate, Forcepoint, Palo Alto, SonicWall. The Cisco we have one brand, the Cisco Firepower, the latest firewall actually. Checkpoint is there, so forth. And there are so many vendors in the market about firewall. Like what we are already we have discussed about what routers, right? Like a D-Link router, HP router, MiFi router, Juniper router, Cisco router. These are the router vendors. So just now we have seen about what firewall vendors. Cisco is a leading manufacturer. Cisco is a leading in which platform is a routers and switches is a very famous actually. Like don't think like a everywhere Cisco is a best for firewalls or routers and switches. Not like that. Like if you're going to purchase a printer, the printer will manufacture so many vendors, right? Like which company printer do you recommend? Is the top brand for the printers? Okay, HP, right? Mostly will prefer what? HP. Like you're going to purchase a mobile phone, like which is the leading in the mobiles now, the mobile marketing, the famous for mobiles, like iPhones, Apple, and Samsung is also leading, right? So similarly, if you want to go for, you're going to purchase a routers and switches. This is the leading manufacturer. Cisco. Now you're going to purchase a firewall. You're going to try to purchase a firewall device. Then which one? That is what I'm trying to tell here. Depends upon the devices. We have a different vendors in the firewall market. In the firewall, at present, it is a leading is a like Palo Alto, Sophos. And the small offices, Sophos is recommended actually. Even the 40 gate, Sonic Wall, even the Barcode also is a leading manufacturer, right? A different vendors. Anyhow, so our topic is not a firewall. Like generally, what firewall will do? So firewall is nothing but security guard. Similar, whatever the security guard is doing the job, the same job will do for network security, network traffic security, right? So how exactly firewall is going to function means when traffic is coming from outside. So what firewall is doing is will stop the traffic, stop it, and examine the traffic is coming from where. What is the source IP address? What is the destination IP address? So which service you are trying to access? Like is all the parameters is going to examine. What is your source port number? What is your destination port number? Like what are the information inside the package? IP packet contains what, guys? Like source IP, destination IP, source port number, and destination port number, and services, TCP service, UDP service, right? Is all each and every parameter. So firewall is going to examine based upon the rules are configured, based upon the ports are configured inside the firewall is going to allow or is going to block the traffic. The same thing, what are the firewall job will do? The same thing router also can do. Router also can do, right? Then what is the difference for a firewall and router? Instead of purchasing firewall, so we already router is required for routing purpose. So for security also we'll use the router also. Yes, we can use the router for security. Router also can examine the traffic and router also can control the traffic, but router can control or can examine the traffic in a basic level only. Not entirely the full-fledged of like dedicated security level is not for the router. So router is dedicated designed for what purpose? Routing algorithm to find the distance, packet switching, packet forwarding. Then one of the option router also can do what? Basic level of security. In our syllabus, we are going to discuss here how router can provide the security in a basic level, like how router can examine the traffic, how router is going to control the traffic. So the short form we can say router is a firewall, right? No. Router is a basic firewall. And the single point you can call is what? Router is also is what? Basic firewall. So that basic firewall technically we call what? ACL. Access Control List. What is ACL? Yeah. What is ACL? ACL is access control list. That we know. Already in the display showing clearly showing in the bold letters, ACL is access control list, right? The first day itself I'm telling is every title, don't consider it as a title. We have a technical concept there. So read one word. Access control list. If we configure RIP in the router 1, router 2, router 3, in 3 routers have configured RIP. Once you configure enable routing, then what happened between the R1, R2, R3? Access is enabled. Like all the users can access any services, right? If all the users are accessing any service, we don't have security, network performance low. Control the network traffic and to provide security, what we are doing is we are going to control the traffic. Like how can control the traffic? By preparing some rules. By preparing by writing some policies. So list of commands, group of policies implemented, configured on router to control the network traffic, to control the flow of traffic from one network to another network, right? So this concept, this we call what? ACL, access control list. Let me explain clearly once again what is exactly ACL. Nikhil, can you hear me, Nikhil? Right. See, inside the head office, I'm writing some rules. In branch one, which users can communicate, which users traffic you're going to block. First user, second user should not communicate, right? So what is the first user IP address? So first user IP address, let me prepare one list here. 192 dot 192 dot 168 dot 2.10. So this user should allow the traffic or should not allow the traffic? Should not allow, right? So means what I'm doing is I'm going to write the command is block the traffic. So 2.10 traffic should be. The second rule is 192.168.2.20 traffic also what? 192.168 3.10 traffic. 3.10 in branch office to first computer traffic. Allow or block? Block. 192.168 3.30 traffic. 3.30 branch to third computer. Block. Perfect. Now 192.168 dot 192.168 dot 2.30 2.30 computer traffic is what? Allow. 192.168 dot and 3.20 traffic. Allow. So these are the list. These are the rules. These are the policies. So this list we call what? ACL. So now you tell me, guys, by using a list, what we can do? Why this list is being prepared? Why the list is being configured? Why this list is being enabled in router? So what is the main purpose? So generally, identify who traffic block are allowed. Verify the block allowed. No authentication. So actually, why these lists are being prepared means, again, I'm repeating ACL. In the title itself, we have the full concept. A is what? By default, when you configure the RIP protocol for all users, they have access to within the LAN, right? Not within the LAN. For your head office LAN also, they have access. So that access, what we are doing here? What are you doing? What is the C? Control. Okay, by controlling the network access, what advantage we can get? By controlling the access, what we can advantage? The first point is by controlling the traffic, we can provide security. Our network is secure now. Like before, we have 100 users, but out of 100 users, we limited. We have permitted only 2 users. So remaining all user traffic is being blocked, right? Then our network is obviously secured. Even the network performance also very improved. So this is how, as a network engineer, we are going to provide the network security in our companies. So this is how we are going to improve your network's performance also by controlling network traffic. So how to control the network traffic means we need to configure ACL. We need to prepare the list of the rules. So which users traffic want to allow, which user traffic want to block. These all the rules are made by network engineers, right? These all the rules, is all the commands where we need to configure in router or in firewall. Actually, we configure in firewall, but router also can support for the firewall. So now in our syllabus, we are going to discuss about what? Router. How router can control this traffic. Right? So what is ACL means? ACL is a list of rules, group of policies, number of commands are configured inside the router to control the flow of traffic from one network to another network. By controlling network traffic, we can improve the network performance and we can provide what level of security we can provide by using ACL. Like high level of security or basic level of security can provide by using ACL, by using router. Basic level. So ACL. So in interviews also they can ask the question, what is ACL means? ACL is a group of commands that are configured inside the router to control network traffic. And by implementing ACL, we can provide what? Network security in a basic level, and it can improve network performance also. Right? You can see the notes. Access list are a group of commands or policies or the rules configured on router to control the flow of traffic from one network to another network. Like what type of security ACL can provide? ACL can provide layer 3 and layer 4 security. What VLAN can provide? VLANs can provide what level of security? Layer 2 security is very important point, guys. Like in the to become the network engineer in interviews, surely they can ask the question, what is VLAN, what is ACL? Both are security only, right? But what is the level? What is the layer of security will provide? VLAN can provide within the LAN layer 2 security. But ACL layer 3, layer 4. What is layer 2? Layer 3, what is layer 4? What is layer 3 and layer 4 is what? Layer 3 is a network layer. Okay. Layer 4 is what? Transport layer. What is mean by? ACL provides layer 3 means network layer security, transport layer security. Did you understand what happened? What is the statement exactly here? Not like that. Network layer means in network layer, actually, which devices and which address will come in the network layer? The network layer device what? Router. Router will works with which address? IP address. So based upon the IP address, source IP, destination IP, ACL can control the traffic. So what is ACL is doing is control the flow of traffic, right? Is control the traffic based upon what? Based upon layer 3 address, based upon the source IP and destination IP. Not only layer 3, it provides what? Layer 4. In layer 4, which layer? Transport. In the transport layer, which protocol will come in the picture? TCP and UDP. Like TCP services are what? HTTP service, HTTPS service, like FTP service, SMTP service, like DNS is a UDP and DHCP. Like out of all services, like what I'm telling is, I can permit FTP, I can block the SMTP, I can permit the DNS, I can block the DHCP. So like based upon the services, also you can control by which one is a ACL. So this is what we are telling is layer 3 and layer 4 security. So don't think layer means network layer security, transport layer security. Actual the terminology is what? Main is what? Based upon source IP and destination IP, we can control the traffic. And based upon the TCP, UDP services, we can control the traffic, right? So and so user is trying to access FTP. Given, you can see in our network topology here, 2.30. 2.30 traffic is allowed. Which traffic is allowed? 2.30 is allowed, but which service is allowed? So this user allow only what? Mail, FTP. Mail FTP means which layer it is? Layer 4. 192.168.2.30 means which layer it is? Layer 3. What we are telling is ACL can provide layer 3 and layer 4 security. Okay. Yeah. Don't get tension. Like complete our concept we are going to discuss based on this slide only. So try to more focus on this slide. Again and again, I'll back to this slide. I'll preview this slide. No problem. First, copy of this slide notes. So what router will do? Router examines each packet to determine whether to forward or whether to drop it. Based on what? Based upon the conditions. So we have specified the conditions. These are all the conditions. So based on these conditions, what ACL will do is going to control it. You can copy it now. Let's copy. So clearly we have defined here what ACL will do. Controls network traffic. For what purpose? To improve network performance, provide basic level of security for network. Now let me say clearly ACL terminology, which is very important topic we are going to discuss now. Try to more focus on it. All of you, can you hear me? Hello, can you hear me, guys? Okay, Ankita. Right. So back to our topology here. Try to focus on it. By using ACL, what traffic we can control? We are telling is what ACL can control flow of traffic. What traffic ACL can control means? So my requirement is a now rule number one. 192.168.2.10. So 2.10 means only a single computer IP address, right? So means by using ACL, we can block. What traffic we can block? In ACL terminology, blocking is nothing but deny. What we deny means a single host traffic. A single computer traffic we can deny. But my requirement is in branch office 1, 2.10 should not communicate, 2.20 should not communicate, 2.30, 2.40. Like how many users actually in the branch 1? 100 users. Like all 100 users should not access my head office LAN. Then what we need to do? So you want to write me a 2.10 block, 2.20 block, 2.30 block, 2.40, 2.41, like 100 commands, 100 statement we need to define here. Then how? Yes, Rakesh? Very good. So what we do means I'm just adding, no, not Sunny, not range actually. So what I'm doing is instead of 2.19 to say 2.10, what I'm doing is, 2.0 block. 2.0 block means what, guys? A whole network, right? Means 2.10 will come in the picture, 2.20 will come, like 2.30 network ID, exactly. Means the whole network is being blocked. Means what is the range? 2.1, 2, 2.254, like all IPs are being blocked, right? So ACL can control a single host traffic, a whole network traffic also. Entire network traffic also can be blocked. Entire network. Okay. So I'm not using the whole network. What I'm doing is I have customized. I'm using /29 here. /29. Now I'm using here subnets. The ACL can control this IP address traffic. If it's a default network, okay. Now what about now? So that is what we already clearly discussed. ACL can provide layer 3 and layer 4 security. What is layer 3? IP address. It can be any IP address. It can be customized IP address or default network, whatever it can be controlled. Means ACL can control not only network traffic, it can control what? Subnet traffic also. Subnet. So I repeat once again, blocking is nothing but in ACL terminology is what? Deny. And a single host traffic, a whole network traffic, subnet traffic. The same time, so what is the rule I have defined here? Mail should permitted. Remaining all services blocked. Here FTP is permitted. Remaining all services what? Means ACL can control, ACL can block services traffic also. Services also, right? Services. So this is the first terminology about ACL. So you try to understand what is meant by deny. Deny. Deny is nothing but what, guys? Blocking in it. So ACL can deny what? ACL can control a single host traffic, a whole network traffic, subnet traffic, and service. ACL not only denying, ACL can do what? Allow the network also. Allow. Allow means in ACL terminology we call it as a permit. Going to permit the traffic. What traffic ACL is being permitted? Only single host traffic, or whole network traffic, subnet traffic, or service traffic. What exactly ACL is going to permit means? Yeah, exactly, Ram. Is going to permit the single host traffic and whole network traffic and subnet traffic and service traffic also. So what I'm telling here, you try to understand the two points about what is deny, what can be denied, and what is permit, what can be permit. Clear? Are you getting the points or not? Super. Okay, right. Now next point number 3 is from day 1, from March 30. From day one itself, I used to call one some point is source address, destination address, source device, destination device, right? So what do you mean by exactly source address and destination address? What is the source device and destination device? Can you please tell me? From day one itself, I'm using the word, right? Source address, destination address, source IP, destination. What do you mean by source IP address? Traffic initiated, traffic arrival. Okay, exactly. So source address means what? Where exactly traffic is being initiated or started, starts. Where traffic is starts, or we call source address. What is destination address? Where traffic is ends. That is what? Destination, right? Now let me ask you one small question here. From branch office to hello, guys, can you hear me? Right. Now my question is here. Branch office to first computer is trying to communicate with head office server. I repeat once again. Branch office to first computer is trying to access head office server. Now you tell me guys which is a source and which is a destination. 3.10 is a source. Okay, good. Destination is what? 10.100 is a destination. Perfect. So what do you mean by source? Source device means where traffic is initiated. The same thing like in your real time also in your organization also you should able to find out which device is a source device, which device is a destination device. So here in the classroom, okay, yeah, okay, clearly, but don't get confused when you're in the real time. When you go for organizations, so there also you need to identify which device is source device, which device is a destination device. Like how we can understand in the real time means this only the one logic is just keep in mind from where traffic is being starts, where request is starts, that is source, where the request is and that is what destination. It can be any device. It can be user's mobile phone, it can be user's computer, it can be user's laptop, or whatever, where the traffic is being initiating, that is a source device, where the user is going to hit, the way that the user is trying to access the resources, that is a destination. Like one of the employee in my company is trying to open the Facebook page. So one of the employees in my company is trying to open the YouTube page. Now you tell me, guys. So by accessing the Facebook and YouTube, my office organization bandwidth is wasted. Not only that, when he's trying to access the Facebook, attacks will come in the picture, right? So means my network is not secured. Then what I need to do as a network engineer? What I need to do? I need to control the traffic. So to control the traffic, I should know about which is a source and which is a destination, right? So now you tell me, guys, which is a source and which one is a destination. Yes, please. FB is a destination, right? Like my employee. Like office employee is what? So that employee IP address, based upon that employee from which computer he's trying to access that IP address and Facebook IP address, we need to put in the router or ACL or firewall actually. Then when the user is trying to go outside, what firewall is doing is no, 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 user, you are not permitted. You are permitted only for mails, but you should not access to Facebook. It's going to drop the traffic. Okay. So here, the next one is a point number one. We discussed about what is denied, what can be denied, what is permit, what can be permitted, and one more point is a source address and destination. Source address means a request. Destination address what? Request. The same example. Now 3.10 is a source and 10.100 is a destination. Now from which computer traffic is being starts? 10.100 or 3.10? 3.10. Now from 3.10 traffic is going to start. Now we need to more focus on it here. Of you guys, can you hear me right? So from 3.10 data traffic is being starts. Data traffic from 3.10 is coming to which interface? Actually, your LAN is here, fast Ethernet 0/0, head office, FT 0/0. Okay. Now tell me, if 3.10 traffic is being started, the traffic is coming to which interface, guys? Fast Ethernet. The traffic is coming to the interface. This type of traffic, traffic is enter into interface. Traffic is coming to the interface. This traffic we call what? Entered, inbound traffic. Like after inbound, like after coming the traffic, what fast Ethernet port will do? Packet switch to serial interface. Packet switch to serial interface, right? Not data in serial. What serial interface will do? Packet forward to head off. Now what exactly happening in the serial interface? Traffic is coming to serial interface or traffic is leaving from serial interface? Traffic is leaving from serial interface, right? Traffic is going out from serial interface. So this traffic we call outbound. Again, traffic is coming to head office serial, right? This traffic is what here? In. Again, packet switch. Fast Ethernet. Here we have what? Outbound. Where on fast Ethernet 0/0, traffic is out. In fast Ethernet 0/0, we have configured what? ACL. ACL is nothing but what? Basic firewall. So basic firewall, what firewall will do? Security guard. What security guard will do? Will stop the traffic. So means here traffic is not examined on a branch office to fast Ethernet or serial or head office serial. Where exactly the traffic is going to examine? Head office fast Ethernet, we have implemented ACL here. So when traffic come to head office fast Ethernet, so here your traffic is going to filter. Here your traffic is going to examine based upon the you're already prepared some list, right? Based upon the rules, your ACL is going to filter out. No, actually, traffic is coming from 3.10. Let's check the rule list. The rule list 3.10. We have 3.10. What is the rule? Block. Blocking is nothing but what? Deny. Okay, sorry, user. Your IP is on my rule list. I'm not going to allow you. It's going to stop the traffic. So the next point also here you should know what is inbound and where traffic is outbound. It is very important. 6 points is the 6 points. So to implement the ACL, to provide the security, to improve the network performance, every person should know these all the 6 points. Then only we can implement ACL properly. If you don't know what is deny, what can be denied. So if you don't know what is permit, what can be permitted. If you're confused where is the source address, which is the destination address. If you don't know about where traffic is inbound, where traffic is outbound, if you're confused, then how we can implement the ACL properly? It's not possible, right? With the half knowledge, if you implement the ACL, you know what happens? Entire network is going to drop. Entire network is going to block. It's very dangerous before that, right? Before we have only what? Network performance low and security. But if implement ACLs improperly, Now what happened? Even your internal users also will not able to access the FTP service. It's very dangerous. So as a network engineer, we should aware clearly about what is a deny, what can be denied, what is permit, what can be permitted, and where the traffic is starts and where the traffic is ends. Source IP address, destination IP address, where traffic is entered, where traffic is out living. I mean inbound traffic and outbound traffic. Clear, guys? Yeah, Angita, like we are not blocking the our network, we are blocking the branch one network. We're blocking 2.0. Right? Give the notes for this terminology, ACL terminology. Point number one, deny, permit, source address, destination address, inbound, income. ACL can block a permit, whole network traffic, subnet traffic, a single host traffic, as well as what? The service traffic also, right? So can you tell me some services example? What services ACL can be deny or can be permitted? Please send me some services. HTTP, HTTPS, right, FTP. Send me fast. HTTP, HTTPS, FTP, yeah, SMTP, DNS, DHCP, Telnet, right? HTTP port number. Do you remember what is the HTTP port number? Port number 8. Very good. HTTPS port number. Very good. 443. FTP port number. Right, round 21. Okay, good. SMTP. Very good. 25. DNS. 53. Good. DHCP. 67. 68. Yes, and it's 23 is a terminal, right? Okay, good. Right now, what I'm telling here exactly means now ACL these all service will comes under majorly two protocols. Which one? HTTP, HTTPS, FTP, SMTP, Telnet. Is all services will comes under TCP protocol. Like DNS, DHCP, TFTP is all services comes under which protocol? UDP. ACL is going to control which traffic? TCP protocol traffic or UDP services traffic? Which protocol traffic ACL can be filtered? Very good. So ACL, not only TCP services or not only UDP services, ACL can be filtered both TCP protocol services and UDP protocol services. The thing is, not only TCP and UDP, ACL also can be control IP protocol, IP services and ICMP services also. So just now we have discussed what TCP. TCP has a HTTP, HTTPS, FTP like this. And UDP also DNS, DHCP. What is IP? Like ACL can be controlled what layer 3 means what? IP is a layer 3. IP V4 as well as what? IP V6. Now what is ICMP? ICMP means ping traffic. So user is always sending ping to my network. Bandwidth is waste space. So generally 2-3 packets is enough to check the network reachability, right? So what some user is doing is keep on sending the ping traffic towards my network. Always is he continuously ping traffic. Some bandwidth is being utilized, wastage of bandwidth. That ping traffic, you want to stop it, you want to block it, you want to control it. So ICMP is the protocol. ICMP is a protocol come in the picture. ICMP means ping traffic. So ACL, so these all the services, all the protocol traffic can be allowed or can be blocked. Which protocol traffic means this protocol traffic? IP, TCP, UDP and ICMP, Internet Control Messaging Protocol. Okay guys, right. Now here have a two scenarios. Scenario number one, first case, have a device. The first case, device IP address is 10.0.0.10 is IP address. So this user 10.0.0.10 traffic, this user IP address should not communicate to HTTP. Should not communicate for what? HTTP service. This is my rule. The second case, computer IP address is 192.168.1.10 is this computer IP address. So this computer can communicate only for HTTP. So for this computer, remaining all services are blocked. Which one? 10.1.10 computer. For first case, for 10.0.0.10, HTTP is been blocked, remaining all services are permitted. So how we can write the list? How we can write the rules? How we can write the policy? Tell me the command here. So first one is, what is the first computer IP address? 10.0.0.10. This user traffic is blocked or allowed? Block means what? Deny. Very good, Ram. So 10.0.0.10 traffic is what? Deny. Which traffic is denied? Which service is denied? HTTP. HTTP port number? So we have to write the command 10.0.0.10 deny 80. This is the command. 10.0.0.10 deny 80. So once if we define this command, now from this computer, HTTP service can be possible? No. Okay. From this computer, FTP service possible, guys? So from this computer, telnet is possible, guys? You are all are wrong. No, not wrong. Why? Because we denied 10.0.0 denied 80. 80 is denied. Okay, I agree. HTTP is denied. What about other services? So other services we didn't define either permitted, either allowed, right? Your thinking is allowed, but did you define here anything? We not define anything right here. We just denied what? Port number 80. That is, I agree. Port number 80, okay, is going to deny. What about other services? So other services, we didn't say anything, either permitted, either denied. So what ACL is doing is, by default, if we don't define anything, ACL is going to deny the traffic. Means in this scenario, not only HTTP, like remaining all services are being denied. What we need to do? Now we need to define like this. 10.0.0.10 permit FTP, 10.0.0.10 permit telnet, permit 23, permit 24, permit 25. Like how many services are available? Thousands of services I need to again need to permit, right? Is it not possible? With the single statement, the single content, with the single line, we need to define HTTP has to block, remaining all services should be permit. The same command with a single statement, we have defined that. How we can define? So to define like that, we use some operations. We use some operators here. So that operators are 10.0.0.10 deny EQ80. EQ is operator. EQ means equal to. Right? Now read the sentence now. 10.0.0.10 deny equal to port number 80 means I am telling to ACL exactly equal to port number 80 only have to deny. It means what? It means remaining all services permitted, right? If we don't define the EQ command, we are denying 80, okay. What about other services? We are not defining anything. But here, once if we use EQ command, now what my router, what my ACL can understand means, okay, the user network administrator is telling is that what? You want to deny exactly equal to port number 80. Then I can deny only port number 80 equal to port number 80. Means what? Remaining all services are permitted. Are getting my point, guys? So here once you define deny equal to port number 80 means port number 80 is only denied. At the same time remaining all service are permitted. Okay. Now you tell me guys, second case, the second statement, how can define the command? Second scenario. This one. 192 dot 168 dot 1.10 1.10. No. See here. 192 168 1.10 deny 80 is the statement. The actual statement is what? HTTP should be permitted. Remaining all services what? Denied. Then what we are need to do means use NEQ. NEQ means what guys? Not equal to. So what ACL can understand now? 1.10 denied. So this computer denies what? Which is not equal to port number 8 is denied. Port number 8 is not denying here, right? So means what? Port number 8 is permitted. So what it is going to deny? Is going to deny all which is not equal to port number 80 means port number 79 is denied, port number 78 is denied, port number 77 is denied, port number 23 like remaining other than port number 80 which is not equal to port number 80 means remaining all services are denied. So this means what? What about port number 80? Port number 80 is being permitted, right? Exactly. So this is how we can implement the ACLs in a single statement to permit zones on service to deny remaining all services by using some operators EQ, NEQ, LT, GT, less than port number 80, greater than port number 80. So these all operators we use actually, right? So yeah, EQ, NEQ, LT, GT. Okay, guys. Generally, we use define this all the commands in the firewall. But we define the router also. Yeah, router also. Router itself, we are going to define this. Yeah, exactly right. Question, Swani, is the Facebook and YouTube and all. We cannot define inside the routers. And router can be services been blocked. Specific website blocking is only possible in firewall. That is the reason I'm telling is what? Yeah, Rakesh. The CCN level, we just router security only. Browser and even the URL block and website blocks, and this comes under like cyber security professional classes. So who are interested to do like a cyber security professional, you can continue with your package to cyber. You can convert your course to the cyber security professional course, and you can get all those things like in ethical hacking or cyber security professional. There we can get all those things. Like generally, these are the commands we use to block in checkpoint firewall, Palo Alto firewall. Like firewall is nothing but controlling the traffic by examining the traffic. Right? Proxy means we are bypassing. Proxy means what? Bypassing. Uh, Rakesh, you want to write the CCNA. You want to begin the CCNA certificate, CCNA exam. So instead of Rakesh, I'm going to write the CCNA certificate on behalf of you. On behalf of you, I'll write the CCNA certificate and your certificate, the name, everything, and idea about yours, the person, and I'm going to write the exam. It means what? Proxy. In a Cisco exam, the exam center, they have a security is there. Security guard is there. What security guard will do? When I enter into the exam, they'll stop me. Show me your ID card. Are you Rakesh? No, you're Balu. Okay, sorry, sir. I don't want to. I allow only Rakesh. And how I can write behalf of you? This is possible actually. It's possible. We'll see later. Who are interested to write the season exam? Let me contact and we'll do that also. No problem. It's secondary, but just telling I'm that is what is a proxy and what is a firewall, right? Right. Yeah. Let me continue. Even we have some scenarios is there. Not we cannot say like the firewall is a weak. Uh, every device we have some what do you say like we have some vulnerabilities is there. Every device. See, Minas, the single one point I can say we don't have 100% security anywhere. Not say firewall is also a complete network security. Even if Facebook has hacking, everything is hacking, right? That's it. So let me explain one small scenario. Everyone, try to involve in my topic here. Is my home. Okay, let me design like well, this is my. So generally, what we'll do, we'll compound wall. Without compound wall, can you construct the home? No, right? Why compound wall is required, guys? For what? Security, protection. Yeah, you come in the technical like terminology, Rakesh, right? Security, right? Okay, security. For one point, we have a fire compound wall. The first case security. So we have the fire compound wall. A compound wall is there. Then without doors, without gates, we construct a home. Why? We have a compound wall, right? Then why you are going to making a very big door with very high end lock and systems? Right? Why? Okay, high jumpers like okay, very good. Means there is one vulnerability there. There is a chances, right? Okay, good. Okay, this is my main door and is my back door, and we have some doors is there. What we'll do? All the doors we keep the locks. Right. Security level 2. So we have locked the gates and everything, and this is my almara in my home. Right. So we have the compound wall is there, and we have a doors are available and is locked. And without lock your almara, do you sleep? Generally, you used to lock, right? Why we are locking? We have the compound wall. Already we have a like your entrance gate is there. This is locked also, but still we used to lock your almara, right? Okay, almara is being locked. Like inside the almara, again we have a different like shelves and racks is there, right? Inside that also we used to what to do? We'll go to lock, right? Why? Same point. The same thing. So still, so even the compound wall and we keep the security guard and will the main gate will keep the and we're going to lock also and we're putting the CC camera also. and even the almara your key, and inside the almara is key also, right? Still, do you think your cash and gold is secure? Partially in your mind, one side you're running, right? Maybe the lock is also being stolen and you can comment, right? Same thing, your network security also. The same thing, network security. When we are keeping the firewall, so maybe firewall is being bypassed. Again, we're keeping the one more advanced device. Maybe that can be bypassed. So what we need to do in the real time means how many levels of security we are putting. That is the main point. So generally, for a house here, security 1, security 2, security 3, level 3, level 4, level 5, like number of 5 levels. Now attackers have to cross how many levels? So first they have to hack the compound wall. Again, they have to enter into a room. Like again, you have to enter almara, right? So we are making number of layers security. So this is how only we need to provide security in your real time also. So there is no single layer security. That can be, right? Important. When you companies, how many layer you're going to protect? Okay. So one of the layer we are discussed about is ACL. Okay, guys. Okay. Come to the topic, and here we have wildcard mask. So remember we have discussed about wildcard mask on which topic? Wildcard mask on which topic we have discussed? Perfect. OSPO, right? In the OSPO uh, configuration, network ID, wildcard mask, and have informed the wildcard mask formula also. Global subnet mask minus subnet mask. So now we are going to clear discussion about the wildcard mask, how it works, and why we use wildcard mask. Instead of subnet mask, why wildcard mask, and how it's going to work? The complete technology, the logic let me discuss about wildcard. Okay, guys. Read the 3 points. It's the inverse of the subnet mask. Hence, it is also known as what? Inverse mask. First point, okay, we clear about it. Second, point number two is point number 2 and point number 3 is very important. Try to understand here. A bit value of 0. 0 indicates what? Mask match. Like it can be any IP address as subnet mask. Complete is a binary language, zeros and ones only, right? The zeros and ones, a bit value of 0 indicates what? Must match. Check the bits. Any bit with a once. Once means what? Ignore it. Here are the 2 points. A bit value of 0 indicates must match. 1 indicates what? Ignore. Let me write some example. 255.0.0.0. 255 means how we can write in the binary? 1, 2, 3, 4, 5, 6, 7, 8. 0 means 1, 2, 3, 4, 5, and something like this. Zeros. What is telling here? A bit value of 1 indicates ignore. Means ignore the first octet. Wherever 1 is there, ignore it. Wherever 0 is there, it should be matched. For detailed explanation, let me take one scenario. So my scenario here, 192.168.2.0. A whole network ID I need to deny. This is my rule. As a network engineer, to provide the security and to improve my network performance, I'm going to control the whole 2.0 network traffic and do what? Deny. Let me write the network ID here. 192.168.2.0. So to deny this is a class A or B or C? Class C network. So for class C network, what is the subnet mask? Subnet mask is 255 dot 255 dot 255 dot 0. So 255 means once, right? So what is the 1 indicates? A bit value of 1 indicates what, guys? Ignore it. Means first octet, ignore the first octet. Here 192 is there, or 193 is there, or 194 is there. Whatever any value, first octet, ignore it. Because we write here is what? 255. Here once is available. Ignore the first octet is telling it. If you ignore the first octet means I am writing 0. What about second octet? 255 means what? Once. So we need to matching or is ignore it? Second octet. Second octet is also is what, guys? Ignore. Write 0. Dot. Third octet. Ignore. 0. Fourth octet. 0 indicates what? 0080. Means it should be matched. In the fourth octet, whatever the value is there, it should be matched. The fourth octet here is 10. Match it. Here is a 9. Match it. Here is a like 20. Match it. Whatever the fourth octet should be matched. But as per this example, what is the fourth octet? 0. So as is 0, I am writing here. Rule is what? Deny. Actually, 192.168.2.0 I am to deny. But if I use submit mask, finally, what we are going to deny here? 0.0.0.0. The whole network is being, I mean, the whole global ID. Complete global ID is being denied, right? But my intention is what? 192.168.2.0 have to deny. So this is the problem with submit mask. So instead of submit mask, let me use wildcard mask. Let me see it. 192.168.2.0. So now tell me, guys, what is the wildcard mask of this IP address? Wildcard mask is what? 0.0.0.255. Okay. 0 indicates what? A bit value of 0 indicates what? Ignore or must match? Must match. So whatever the value in the first octet, it should be matched. The first octet have a 192 or 193 or 194 or 200. Whatever the first octet should be matched. So is matching as easily 192. Second octet, 0 indicates must match 168. Third octet must match 2. Dot. Fourth octet is what? Ignore it. 0. Rule is now exactly whatever my intention, I have denied 192.168.2.0. So exactly we have denied by using submit mask or by using wildcard mask? By using wildcard mask exactly we have denied, right? So this is how exactly wildcard mask is going to working. To match each and every octet, we use what? Wildcard. Okay, now next example, one more scenario here. My policy is 192.168.2.30. Only one computer, only one host traffic can you deny. The computer is 2.30 IP address. So now we have to use a subnet mask or wildcard mask, guys. Which one? Which is the base? Subnet mask or wildcard mask? Wildcard mask. Now you tell me what is the wildcard mask? 0.0.0.255. Okay, guys. First octet matching 192. Second octet matching 768. Third octet is matching 2. What about fourth octet? Ignore it. Ignore means I'm writing is what? 0. So actually I want to deny the whole network or only single host IP address. Since is only one single IP address and you deny, but even if you use a wildcard mask, also a whole network traffic is going to deny, right? How I can block only single host, only a single computer traffic? How we can deny? So for single host, for single IP address, wildcard mask is a all 0. me show you an example here. A single host 192.168.4.38 traffic you want to deny. Now you know what is the wildcard mask? 0 dot 0 dot 0 dot 0 is a wildcard mask. So once if with the 4 zeros, now what does 0 indicate? Must match. 192 is matching. 168 is matching. Third octet is matching. Fourth octet is also matching. Now I can deny. So for single host, wildcard mask is what? All zeros. For a host is 000 is a wildcard mask. Can you copy it now? Not only submit mask, one is matching. Even submit mask also 0 is matching, one is ignored. Wherever the value 0 indicates what? Right. Now let me say clearly about working of ACL, how ACL has been working. How it's been working. Point number one, works in a sequential order from top to bottom. I repeat, ACL works in a sequential order from top to bottom. Have the list 1, 2, 3, 4, 5 number of rule list is in. Any traffic is coming from outside. What ACL will do? Okay, have a rule number 1, rule number 2, 3, 4, 5, 6, 7. When data traffic is received to ACL, what ACL is doing is it's going to sequence ladder from top to bottom. Rule number 1, is it matching? Not matching. We'll go for second rule. It's not matching. Potato is not matching. Like sequence ladder from top to bottom. Let me take this is example here. See, rule number one, rule number two, rule number three, rule number four. In our example, how many rules are available here? Four rules. This is my list, ACL list. Branch office to first computer. 3.10 computer is trying to access 10.20. I repeat, 3.10 user is trying to communicate with 10.20. So 3.10 is a source, 10.20 is a destination. From 3.10, the traffic is being generated. So I will come to fast Ethernet is a inbound traffic. Traffic is to serial, outbound. Again here inbound and head office fast Ethernet traffic is outbound. Here we have ACL firewall. We stop that. Now how it is going to examine? The examine process is this. What is the process? Sequence ladder from top to bottom. Now data is traffic. Traffic is coming from which IP address, guys? From 3.10. So 3.10 is a source. After receiving ACL, what ACL is doing is, okay, wait traffic, let me check in my list, rule list, you are permitted or you are blocked, let me check. So how is going to verify? Or directly will come to the rule number 3, okay, you have a 3.10 is going to block, not like that. What ACL doing is going to check first rule number 1. Rule number 1 is a 2.10, but traffic is coming from where? 3.10. So rule number 1 is not matching. So what ACL will do? We'll go for rule number 2, sequence ladder from top to bottom. Rule number 2 is what? 2.20, but traffic is coming from 3.10, is not matching. We'll go for rule number 3. So rule number 3 is a 3.10. So okay, you are also coming from 3.10. Yeah, now rule is matching, like IP is matching. What is the rule? Oh, okay, 3.10, you are not permitted, you are denied. I'm going to deny that. Like this. So once its match is being found, what ACL is doing is, after 3.10, what are the rules are available, it does not check further. If 3.10 is matching right here, so what are the rule number 4, rule number 5, rule number 40, rule number 80, it does not check further rules. That's the point number 2 here. If a match is found, it does not check further. But generally, ACL can function based on what? Sequence order from top to bottom, the rule is. Next point is here. The next scenario is 3.20. Branch office to 3.20 is trying to access FTP server. Which is the source and which is the destination, guys? 3.20 is a source and 10.100 is what? Destination. Okay, very good. From 3.10, data traffic is being started. Here inbound, outbound, inbound, outbound. ACL is going to stop the traffic and now traffic is coming from 3.20 and this 3.20 is trying to access service called FTP. What ACL will do? Directly is permitted. I'll examine the traffic. Check the list, right? So how is the examine? Top to bottom. Sequence ladder. Rule number 1, 2.10. The traffic is coming from 3.20, not matching. All right. Rule number 2, 2.20, but traffic is coming from 3.20, not matching. Okay. 3.10, not matching. Next rule number 4, 3.30, not matching. I have the 4 rules only in my router, but the traffic coming from 3.20, then what router will do now? What ACL will do now? No, Ankita. So if there is no match found in the ACL, so by default is going to deny the traffic and allowed. So 3.20, about 3.20, we didn't define anything, right? Either permitted, either denied. What ACL will do? So I don't know anything about 3.20. Blindly, I'm going to block the traffic. Right away, it's going to block the traffic. So how dangerous it is. So even actually 3.20 users should communicate. But what ACL is doing is going to drop that. What about 3.40, 3.50, 3.80, 3.60? Reminding what about the other users? Other users also has been blocked. This is the point, a very important point to keep in mind. At least one permit statement should be there. Define the permit statement. So here we have a 4 rules. 4 rules we have, right? So 4 rules are what? Block rules. There is no permit state. So what I'm doing is rule number 5 I'm writing is a permit. Like which traffic you need to permit now? Which user traffic you need to permit now? 3.20. What about 3.40, 3.60, 3.70, 3.80, 3.20? What I'm telling is permit. Who are the block list? Who are you is going to deny? So we need to deny the rules of first one, top one, top side completely. We need to write what? Deny. Once deny rules are been finished, then you can go for what? Permit rules. Now see how it is going to work. 3.20 traffic is coming. Rule number 1 is not matching. Rule number 2 is not matching. Rule number 3 is not matching. Rule number 4 is not matching. What is the rule number 5? Rule number 5 is permit. You can be 3.20 or 3.21 or 3.22, whatever. Permit any. Now it is going to permit. So here you have to understand, without permit statement, if you write the rules, if you write the policies, if you implement the ACL, remaining all users traffic also is going to block. At the same time, your job is also blocked, right? So very important point is what? Permit statement. There should be at least one permit statement. What happens if there is no permit statement? An implicit deny blocks all traffic by default when there is no match. An invisible statement. If there is no match, is going to drop the traffic. One practical example. Now we can get very clarification here. We have purchased router. For router, you have connected to internet cable, ISP, and router to switch, and switch to end user. ISP keys have paid amount, and ISP is providing internet, and your serial port is being configured IP address, and serial port is upstate. Your LAN port is also activated upstate. Inside you have configure routing protocol also is everything is good and fine. Connectivity, connection, everything is okay. But still, end users should not get internet access. Why? What was the reason? The reason is inside the router, we need to define the permit statement. So permit any until unless you don't get internet. So just your cable is connected. So what router is doing is by default your internet traffic is being blocked, denied. So manually we define the permit statement, then only you can get internet. So that is the point here. There should be at least one permit statement. What ACL will do? Deny blocks all traffic by default when there is no match. So that is also one of the very important point you need to keep in mind in the real time. Your organizations, your office router, if it is not allowing the traffic, if it is not allowing the traffic, then log into router and give the permit statement command and check permit statement whether it is enabled or not. Have purchased one brand new router. You are the network engineer. Have purchased one router. Have configured, host name configured, IPs configured, IPs are active, pinging, everything is going good. And ISP connected, okay. You have called the ISP also. ISP is telling, sir, from my end is everything is okay. But still, if you are not getting internet, means what was the problem, guys? You're not permitting. You're not defined the permit command. Okay. So new entries are automatically added to bottom of the rule list and can have one interface on one ACL for each interface. Copy. Wait a minute. See, that the traffic is different. I'm telling about Pradeep. I'm telling about internet traffic. Generally, R1, R2 connected. And if we configure here RIP and here RIP, then they can directly can communicate, right? I'm telling is what? So this is what R1, R2 communication means branch one, branch two communication, enterprise network communication. But R1 LAN users want to communicate internet like a public services, like public Gmail, Yahoo Mail, Facebook, Twitter, YouTube, like internet access. So for internet access inside the router, now we need to give the permit statement. For your R1 to R2 router, like this is the permit statement is not required. Okay, you get the point, Pradeep? Yeah, exactly right. See here, there are two different type of networks. One is from your R1 router to R2 router, R2 to R3 router. That is a Zoom branch one, Zoom technology branch two, Zoom technology branch. Between the three branches, to enable communication, you can use what? Routing. It can be static or dynamic routing. So when I configure static or dynamic routing, now traffic can reach here and traffic can come and go. No problem. But thing is, these Zoom employees want to access internet, public network. Then inside the router, we need to define permit so and so public IP. Then only from outside traffic will come to inside. They can access internet. Otherwise, it's been dropped. Okay. Right. Now let's see types of accesses. So we have two with IPv4. We can control the network traffic and as well as IPv6 also. IPv4 and IPv6 and IPv4 have two types of ACLs: standard ACL and extended ACL. Even IPv6 have only extended. In standard, we have named and numbered ACL. Even extended also we have the same. We have named only. So let me discuss clearly about what is named ACL and numbered ACL and what is standard ACL and extended ACL. The point here, name and number. So first let me discuss name and number. So here have a five rules, right? The rule list in the ACL have five rules. Is all the rules are being configured with the help of name. We call it a name ACL. Like Zoom ACL. Zoom is the name. Cisco ACL. Cisco is the name. CCNA ACL. CCNA is the name. Act Fiber. Act Fiber is the name. Like Airtel. Airtel is the name. Is all the commands are being configured with the help of name. We call this name ACL. Rest is all the rules are being configured with the help of number. ACL number 25. ACL number 35. ACL number 350. ACL number 450. ACL number 120. Any number that ACL we call numbered ACL. Example ACL. ACL number 25. Statement 1. ACL number 25. ACL number 25. ACL 25 so on IP address and block and ACL number 25 and partner statement. So is all the rules are being configured with the help of name or numbered. So this ACL is a name ACL or numbered ACL, guys? Name or numbered ACL? It's a numbered ACL, right? Okay. Then what is the difference between name ACL and numbered ACL means? If I use numbered ACL, with how many statements are configured here? Rule number 1, rule number 2, rule number 3, rule number 4, rule number 5. 5 rules are configured with ACL number 25. Is a numbered ACL. Right? Like after some time, I want to remove rule number 3 in my list. In my list, I want delete. I want to remove the rule number 3. So generally, what is the command we use in the Cisco routers to remove anything? We want to remove the host name. What was the command? No command, right? No host name, no IP address, no password, like this. The same thing like here, I want to remove the rule number 3. So what is the command? No ACL 25, 192, 168, 3.10 block. Right? Now, once you define the no ACL 25, now rule number 3 is being removed. At the same time, all rules are also being removed. Because all rules are being configured, ACL number is what? 25 itself, right? So what does mean exactly means? By using numbered ACL, we cannot remove a specific statement, a specific rule, we cannot delete, we cannot remove it. So this is the point in the last slide we have discussed. If you see the last slide, the last point of last slide here, removing of a specific statement in a numbered ACL is not possible. Doesn't mean what? Removing of specific statement in a named ACL is possible. Numbered ACL is not possible. Named ACL is what? Possible. So this is only the major difference between named ACL and numbered ACL. The specific statement. Okay. Equal command for the services. EQ command for services, not for this section. EQ, NEQ, LP, LGT is for services. Right? Okay. So this is the major difference between named and numbered. In the named ACL, we can remove the specific statement. In numbered ACL, we cannot do that. But now the major thing is, hey, we'll go for a standard ACL and extended ACL. So what was the standard ACL and extended ACL means? If you see this example here, have two methods of ACL. One is standard and one more is two scenario. Scenario 1 and the first scenario 3.10 IP has been denied. And second scenario also denied, right? So we can deny a device IP address by using standard ACL also, or by using what? Extended also. Anyone you can use it. Then what is the difference means? Like this is my computer. This computer IP is 3.10 and rule is what? Denied. I have used standard ACL. If I use standard ACL to deny the computer, what was the command? Deny. Once if I define the command by using standard ACL, now from 3.10 computer, HTTP is being denied, FTP is denied, SMTP is denied, Telnet is denied, DNS is denied, DHCP is denied. Like all services are being denied. By using standard ACL, if you define the command deny command, now all services are what? Denied. But by using standard ACL, if I define the command is a permit instead of deny, if I use statement is a permit statement, now which service are permitted? HTTP is permitted, FTP is permitted, SMTP, Telnet, like DNS, DHCP, like all services are permitted. So what I'm telling exactly here, if by using standard ACL, either we can deny all services, either we can permit all services. These are only the two things here. We use standard ACL in their companies also, in the real time also. What we can do by using standard ACL? So and so an employee computer, either you have to block them, either you have to permit them, all services. But my requirement is a selected services I need to permit, selected services I need to block for any one employee. Then how we can use it? And how we can implement means now we need to go for what? Extended ACL. In extended ACL, selected services can be permitted, selected services can be denied. In case of standard ACL is what, guys? Either all services are being denied, either all services are allowed. The second scenario here, We use 192.168 2.20 deny equal to port number 21. Then which service is been permitted? FTP only permitted. The remaining all services are what? Denied. Like this. So this is the major differences between standard ACL and extended ACL. But how my device can understand? How our routers can understand which ACL is being implemented by the network administrator? Is standard is implemented or extended is implemented? Like which ACL is being configured means how the device can understand means is based upon the number range. ACL number range. If you use ACL number between 1 to 99, now device can understand it is a standard ACL. If you use number between 100 to 199, now device can understand. So this is extended ACL. So by seeing the numbers range, the device can understand which is standard ACL or okay, guys. Standard ACL. Number range is 1 to 99. Two-way communication is being stopped. All services are either blocked or allowed. Filters traffic based upon only the source address. Guideline we have implemented closest to destination. So where the destination is there you need implementation. That's the guideline. Okay, right. Same topology here. Topology. Now let's see the rule number one here. Implement rule number. So what's the rule number one? 2.10. address 2 dot. This computer is 2 dot 10 dot 3 dot. Now let's consider middle one is a head office. So what is my requirement is 2.10 user should not access my computer. Let me before implementing of ACL, let me check the communication between the two devices. It's communicating. Ping 0010. Okay. Communication okay, right? But my requirement is I don't want to allow this user. Then what we need to do, guys? So this user should not access my computer. So this user, all service should not access, like all services from this computer, no ping, no telnet, no FTP, no SMTP, like all services I need to block for this user should not access to my computer. Then this ACL I need to implement it. Standard ACL, extended ACL. Standard ACL. Okay, very good. Now question number 2. Question number 2 is a which is a source address and which is a destination address. Yeah, which is a source and which one is a destination? 2.10 is a source and 10.10 is a destination. Perfect. Now this rule, policy, command, ACL list, in which router we need to configure? In R1 router or R2 router? Branch 1 router, head office router. Which router we need to configure? So that is a guideline is clearly defined the guideline here. Standard ACL implemented closest to the destination. This is a guideline. The destination is what? 10.10 is the destination. So which is the closest interface for this computer? So this destination computer, which is the closest interface? Fast Ethernet or serial? Which is the closest, guys? Fast Ethernet. So we need to implement it on where? Fast Ethernet. Let me configure the ACL in the head office router. Configuration mode. Access list. ACL number or standard ACL number 1299 can use any number. My example is 23. Access list 23. Source IP address 192.168.2.10 and wildcard mask. What will be the wildcard mask of this IP address? What will be the wildcard mask of this IP address? Yeah, exactly. Ram, you first and you think about twice, right? Yeah, perfect. So 192.168.2.10 is a single host, right? Only single computer you want to do a block, right? Means is a wildcard mask is all zero. So access list 23. What is your rule? You want to permit or you want to deny? What is the rule? Access list 23 deny which user 192.168.2.10 wildcard mask 00. This is the command. One deny statement. Now if you leave like this, deny statement is okay. Only deny statement. Then what happened? 2.10 is denied. What about 2.20? What about 2.30? What about 2.40? What happened 2.20 here now? Then what will you do, guys? For this statement is must. What I'm doing is access list 23 permit any. Permit any. So two commands. First one is 2.10 denied, and second one is two statements. So this is only creation of ACL is not implemented. We need to implement the ACL on which interface? Closest to the destination. Destination is a 10.10, closest is a fast Ethernet. So there we need to implement, let me implement the ACL fast Ethernet 0/0 IP access group number 23 means ACL number. Now in the fast Ethernet, now you tell me guys, which type of traffic? Is a inbound traffic or outbound traffic on fast Ethernet? Traffic from 2.10 is generated. We come to in, out, in, out. And head office fast Ethernet, the traffic is out or in? Traffic is out. Yes. Access access list. Sorry, access group 23 is what? Out. Now if you check once again the communication from source device to destination device. Destination host unreachable. So here only 2.10 PC only cannot communicate. What about remaining two users? Yes, remaining two users can be communicate, right? Let me check. 192.168.2.20 user and the gateway not one. Let me check with another computer 10.00.10. See, getting reply. In the head office router, we have configured ACL list is only what? 2.10 traffic is been denied. But instead of 2.10, if I use command 2.0, then whole network 2.10 traffic is denied, 2.20, 2.30, all user traffic is been denied. Okay, guys? Like this, we can implement the standard ACL. We can copy commands for standard ACL. The creation of ACL and the implementation of ACL. And copy it fast. All right, this is for today. We have discussed about ACL, the standard ACL, and tomorrow we'll continue with extended ACL configuration and implementation, and I will show you the example of ACL. So it's for 10 to 15 minutes. we'll continue with one more other topic. Okay. ACL verification. ACL, like, show IP. So for router, you have the two interfaces, right? Like a LAN interface and WAN interface. Generally, for LAN interface, we use private IP. For WAN interface, we use public IP. Even the WAN interface also we use private IP sometimes. But how concept is that? We'll discuss about the public IP and private IP. NAT and LAN. Okay, Sunish. But just keep in mind, for LAN interface, we use private IP and WAN ports. We use for public IP. Clear, all of you? Any doubts? Right. That's for today. I'm going to end the meeting now, and we'll try to practice on it. Actually, yesterday I got some WhatsApp messages.